Hi, I'm Lindsey with Machine Design Magazine, and I'm here with Dan Herman of NASA Glenn Research Center. Dan, tell us about where we are right now.
So right now we're inside the volume of Vacuum Facility 6 here at NASA Glenn. The facility is 25 feet in diameter and 70 feet long. It's one of our premier electric propulsion testing facilities. It has a very high pumping speed, which we need to simulate the low back pressures that you would see on orbit in space. It also has a completely enclosing thermal shroud, a liquid nitrogen cooled shroud that can simulate the deep space cold soak temperatures as well. Unique capability that this facility has is the ability to simulate solar flux. It has a solar simulator, so it can simulate the solar flux at 1 AU, the distance the Earth is from the Sun, at a 2-meter disk. So we've also done advanced solar ray tests in here as well, which of course are critical to electric propulsion because that provides the power for us to operate those engines.
What type of materials do you use in this facility?
So the facilities are stainless steel, or they're stainless clad aluminum. For electric propulsion, we would like to have a lower sputter yield material. So high energy ion beams, being ejected from these engines has to hit something in a facility, right? On orbit, they just go into space. In a grounded facility, they will actually hit the walls. And so it will remove material from the wall. And you can imagine if you're eating into a vacuum chamber wall, that would be a bad thing because eventually you'd break through, you'd ruin the facility. These facilities cost probably hundreds of millions of dollars to replicate. And so we would line the facilities with carbon material that has a lower sputter yield. It's a sacrificial material, so we can replace plates as they wear out instead of replacing facilities as they wear out.
Now, since we are a magazine for design engineers, every design engineer wants to know what was your biggest challenge in the design of this?
So in the design of vacuum chambers, traditionally for electric propulsion, the challenge is limiting that back sputter rate of material from the facility and also limiting the back pressure. So testing in a grounded test facility does two things. It can increase the back pressure because you have finite pumping speeds. On orbit, it's really infinite. And the location of material that can erode is in much closer proximity to the engine. So a larger volume facility is always better, and a facility with a high pumping speed is also preferred. And so the two facilities here at NASA Glenn do a good job of limiting those effects on our tests and on the thrusters that we're testing here, but are not cost prohibitive. They're not so large that they're very costly to operate.
Sure. Well, thank you. That was very interesting.
Thanks.